Hey guys, Kanal here. How are you? So, in this series, this is the second video. I began with writing a very simple flowchart using Raptor. The first video was titled Reversing a Number. So, we saw the logic that would be applied in case you want to reverse a user given number. So, we saw that yesterday. And I am here with another fresh video. The the way I intend to carry on this series is to build simple programs first and then move on to more complex ones, uh, solve some of the dynamic programming problems using algorithms and flowcharts. Flowcharts mainly because we'll be using Raptor to build all our programs and build our programming logic. And these videos are intended for students who want to learn algorithms, who want to understand dynamic programming, who want to know more about data structures. So I'll be covering a lot of topics. And for today's video, I have selected a typical problem. It's not a very difficult one, but for the beginner, it would be very nice if they spend some time understanding this. So the problem is that given a user input or given a user defined number, you have to check whether the number is a prime or not. And to do that, we will be using a data type or something called a boolean. And a boolean simply means that there can be only two outcomes or result. It could either be a true or it could either be a false. So there can be only two outcomes. So that's the whole idea behind a boolean. I intend to introduce all the data types in a separate lecture. I also intend to introduce you to Raptor in a more formal way so that you understand the tool, how to use it, all the different symbols being used, and what all you could do with it. So, yes, so that would be a separate video that would be coming soon. All right, let's begin. So, let's begin with an input box because we will need a user input. Let me say enter a number. This is basically a user prompt. So we are asking the user to enter a number and I'm storing it in a variable called num. All right, cool. Now, basically, what I want to do, and let me get a comment box here so that you understand. So, what I basically want to do is I want to begin with a, a, a value, begin with a variable. Let's call it I, and I want to begin with say 2. And what I want to do then is that I want to divide the number that the user gave in as an input. I want to divide it by 2 and see if the remainder is 0 or not. Right. So this is basically what I want to do. I want to divide the number by 2 and see if the remainder is 0 or not. If it is not 0, then I will want to set I to 3 and check again. So then I'll do num divide by 3 and see if again the remainder is 0 or not. I want to do this process till I reaches num. And in fact, not even num. I just want to repeat this process till I becomes num by 2. The reason I want to check till num by 2 is because uh, the half of the given number. So anything beyond that is always going to be, always not going to be a remainder zero, not going to be a factor of the number. So it's not going to be a factor, right? Or it's not going to be a divisor for that given number. So anything beyond the half of that number is not going to be a divisor. And we don't really want to check beyond that. Now, this is one method which is naive in its approach. It's a basic method. I mean, you can solve this in various ways, not necessarily the way I show it to you. But since this is a video I am building for the absolute beginner, we'll just stick to what uh, is the most obvious approach. All right, so I'll just keep this comment. Uh, Next step, like I mentioned earlier, we will need a flag. The flag is a boolean, as in a red flag or a green flag. And let's say the flag has only two values, 0 and 1. And to begin with, the flag is 0. So I set the flag to 0. Let me comment this. 0 in flag means that the number is not a prime. Let's begin with this premise that, okay, so let's begin with the premise that the 0 means that the number is not a prime. Now we will build some kind of logic in which we'll check. So we'll do this part here. We'll start with a variable I, set it to 0, run a loop, iterate I, and keep dividing the number by I and see if we get remainder 0. We will be using the modulo operator the way we did in our previous videos. Uh, but let's go and actually build it so that you understand better. All right. So I have selected a loop because I'll need to run a loop here at this stage. I am not mentioning any condition for now. The condition that will make the iterations to stop, or uh, the condition that will make uh, the program exit this loop. All right. So I'm not mentioning it right now. We'll do that at a little later. Now, what I want to do at this stage is I want to begin with a variable. Let's call it I for simplicity's sake. And let me set it to 2 because I want to start dividing my num with this value of I. So what I will do here is I will want to check whether my I, sorry, num percentage of I is 0 or not. And you can see I cannot use this assignment box here. The assignment box is typically used to assign variables with values or do some complex calculations and assign values to that variable. What I basically want to do is branch here. I want to do something like an if else. And in that scenario, I will need a selection box or a selection symbol, which I have selected right now. And now I can do my checking. So let me do num percentage of I. If my num percentage I is equal to 0, if it is 0, which means that it is not a prime. This means that the number got divided by I could be anything. It just begins with 2, but during the entire process, it will keep on incrementing. So at this stage, when the num divided by I is 0, we'll just say that the number num, the input number is not a prime, and we will express it with putting the symbol flag or the boolean flag back to 0. We'll make it 0. That's number 1. And then number 2, what we will do is we will now, since we have found one divisor for num with this condition, we don't want to really continue this loop again. We want to exit this loop. And at this stage, we'll have to find out some way or some condition to be checked for exiting the loop. And let me put that condition to be num or my I is greater than num by. So I just want to run this program till my I becomes greater than num by 2. Beyond num by 2, it really doesn't make sense to check for a factor because there's not going to be any factor beyond that point. So we just want to run it till here. If we don't find a number, a factor till num divided by 2, that means that the given number is a prime. Cool. So we have put a condition here in the loop statement or the loop condition, and this is our branching where we will check if the number is perfectly divided by I or not. All right, cool. So flag I have set here to 0. This is the ES condition branch. Now, if the flag becomes 0, I need not continue this loop again. So to do that, I will just, I can. So there's various ways in which you can exit this loop, but one of the ways that I found to be very easy is that I will create a condition where you exit the loop automatically. Of course, there are ways of breaking the loop. So, if some of you know programming, you may have used a break statement or the exit statement, but we will not use anything like that here, not yet. We'll do that in further programming uh, videos, but here, let me just create a condition. So, what I will do is I'll set my rather I to be n, and do if I set my I to be n, obviously this condition will be not matched. I will be greater than num by 2 and it will exit and it's num. I keep making that mistake. All right. Not met and it will exit this loop. All right. Cool. So what if the num percentage I is not 0? If it is not 0, we will simply set the flag to be 1. And we will then increment the I. So we want to check for the next number, I plus 1. So beginning with 2, we want to check for 3, 4, 5, so on till I becomes greater than num by 2. Then it doesn't make sense to check this any further. Cool. This logic is over. And then finally, I'll use another selection box. I will say if my flag is 1, if it is 1, then I will output given number is a prime. Otherwise, I will say given number is not a prime. Oh, sorry, I'll have to use an output box. So I'll say let's test this. I will enter 13 and it says given number is approved. Let's test it just once more. So let's say given number is uh, the next prime is, say, we'll take one prime, given number is a prime. All right. So do let me know what you think about this program, and I would like to also know from you if there is a better way of solving this. So till our next video, see you guys. Thank you so much.